Good morning again, grade 10. Again, as what I had promised, we left already with Q1 Module 2, weeks 5 to 8. Okay. Last week was the last access. That was our last access for Module 2, Q1, weeks 5 to 8. Okay. Let's move now. This is the formal start of Module 1, Q2, weeks 1 to 4. This is weeks 1 to 4. So therefore, this is good for 1 month or 4 weeks. Okay. Again, I already closed all the activities of the previous module, previous quarter. I am now in the middle of checking all your answers, even the modular. Okay. Please take note and tell your classmates that I had just received few modules from you. There you go. And of course, your grades will be based on the modules you had submitted or your outputs. As simple as that. Okay. And of course, your performance tasks will be based on what I had encoded or what I have uploaded in the LMS. Those are your performance tasks. Right? Take note that performance task is 40% of your grade. Right? Let's move forward. Do you have any questions so far? Before we start? Grade 10?
No.
Are you still with me? Can you hear me?
Yeah.
Okay, so let's start. Our module 1, weeks 1 to 4, Q2, is electromagnetic waves. What's with the electromagnetic waves? How do we interact with these electromagnetic waves? How this exists? What are the usage of this? Let's find out more. Okay. Electromagnetic spectrum. Okay. After Maxwell's predictions, electromagnetic or EM waves were first generated and detected experimentally by accident or by experiment. Okay, by Heinrich Hertz. Hence, we have megahertz. Okay, ultrahertz, hertz. Those are what? Named after Heinrich Hertz in 1887. They are classified as transverse waves. The electric and magnetic fields of EM wave are perpendicular to each other and to the direction of propagation. Let's tackle more about this later, right? The EM waves in the spectrum are arranged according to decreasing frequency and increasing wavelength. Okay, low frequency waves have longer wavelength, while high frequency waves have shorter wavelength. Why is that so? Just like when you are actually holding a rope, okay? When you move the rope up and down, okay, you're actually creating bigger waves, correct? But you are using a what? MD is coming. You're using a low energy only or lesser energy compared if you're actually what? Making it more faster. Okay.
Good morning,
Once
sir.
you're making it more faster, okay, once you move the rope more faster, you're actually what? Consuming more energy. So it has a bigger energy or more energy compared to the slower one or to the bigger waves. This arrangement indicates that there is an inverse relationship between frequency and wavelength. Let's take a look at the relationship later between frequency and wavelength. Okay. EM waves carry energy called radiation. Okay. We are more exposed to this, especially millennials. Okay. Even your phones emits radiation. Aside from that, you are actually sleeping with your phone. Okay, you're putting it on your head, you're putting it on your side, in your chest, and whatsoever. So it emits, again, radiation. This is the reason why the EM waves are also called electromagnetic radiation. Generally, the higher the frequency of a wave, the more energy it carries and more hazardous it becomes. Correct. Low frequency EM waves. Low frequency EM waves include radio waves, the one being used by your radio, okay, and your television, microwaves, okay, infrared rays, and the visible light. Okay, let's discuss this one by one. Okay, let's start with radio waves. Radio waves have the lowest frequency, approximately around 10 to the power of 3 to 10 to the power of 10 hertz. But the longest wavelength is approximately 10 to the negative 3 to 10 to 5, 10 to the power of 5 meters. Thus, this can travel a long distances. This is the reason why it is used mainly for communication. Okay, transistor radios, they're using radio waves. What else? What else? Your walkie-talkie. Okay, it actually uses radio waves. Okay. So, in the diagram, you can actually observe that in a radio wave, it needs a transmitter and a receiver. So once it transmits information or audio, for example, in a walkie-talkie, the receiver actually receives the information. This is how we actually use our television, our radio phones. What else? Our transistor radios. This is the reason why they have antennas also to receive, to transmit and to receive. Right? Radio waves are classified according to their wavelength. Okay, a long wave has a wavelength of 1 to 2 kilometers. Okay, a medium wave has the wavelength around 100 meters. Okay, and is used in amplitude modulation or EM stations. AM stations, your radio. Okay, these waves have the frequency ranges between 550 kilohertz to 1600 kilohertz. The very high frequency of VHF, okay, waves have the wavelength around 2 meters. These are used by FM radio stations, okay, or frequency modulated radio station, and are within the range of 88 to 108 megahertz. Okay. The other class radio waves are called ultra high frequency waves. Okay. They have wavelength less than a meter. This type of radio wave is used for television broadcasting, cordless phone, walkie-talkies, police radio communication, aircraft radios, and other radio communication applications. Have you seen how a walkie-talkie works? Not yet. I'll let you
I
see.
have one like register like frequencies.
Walkie-talkies work by transmission and receiving. Okay, you could be a transmitter and you could be a receiver because it's a two-way communication. Okay, all you have to do is to press the push to talk button. Okay, and then there you go. You can actually communicate with each other with a certain range. These are good in an event, like you want a constant communication with a team. Yes, it is good. It can actually also communicate within around few meters, like around 5 or 10 meters. Okay. Do you have any questions so far?
Sir.
Right. Radio waves are useful form of EM waves, but they also have some disadvantages. Okay. Lower exposure to radio waves may not affect health because of the low energy carried by these waves. However, some health experts say that too much exposure to high frequency radio waves, okay, may cause cancer, leukemia, and other problems because these waves can actually activate the oncogenes. Remember that we all have oncogenes in us. These oncogenes are inactivated cancer cells. But once there is a triggering factor like these frequencies, like these high frequency radio waves, it can actually be triggered and become malignant or cancerous or activated oncogenes, activated cancer cells. That's the problem. Okay, just be careful of handling your phones also. It transmits radiation, and this radiation can actually cause harm to you if in case. Microwaves. Okay, this is really common. You heard a lot about microwaves. You have microwave oven at home. So how it works? Okay, microwaves are basically extremely high frequency radio waves. Since its frequency is very high, its wavelength is very short. Okay. Again, what is the implication if the wavelength is really short? Then it is what? It produces more energy, of course. These waves are produced by various types of transmitters. Mobile phone, for example, okay, uses a transmitter chip to produce microwave, and the microwave oven uses a magnetron, a transmitter that converts electrical energy into microwave radiation. It actually creates heat. This is the reason why when you're talking over the phone for a longer period of time, you can observe that your phone heats up. Correct? Your phone heats up. Why is that so? Why your phone heats up? Simply because it produces microwaves. The transmitter chip produces microwaves, and this causes the phone to heat up. Okay. What else? When you're using your phone with your Wi-Fi, okay, it again creates a microwave. Okay. The chip now transmits microwave and produces heat in the process. Stars are also transmitters of microwaves. Okay, microwaves can also be reflected and absorbed. Can you hear me, everyone?
I can hear you, sir.
Okay, how about others? Dimitri, can you hear me?
Yes, sir.
Okay, MD, can you hear me now? MD?
Yes, sir, I can hear you now.
Okay. Again, stars are also transmitters of microwaves. Okay, microwaves can also be reflected and absorbed. Food is cooked in a microwave oven by absorbing microwaves. Remember that your microwave uses a magnetron to what? To emit microwaves. Okay, and these heats will be absorbed by your food. Okay? This is how your microwave oven works. Okay, metallic objects reflect microwaves. This is the reason also why metallic containers are not used in microwave ovens. Tendency is if you're gonna use your utensils, metallic utensils in your microwave oven, it will reflect the microwave in the oven, and eventually it will damage your microwave oven because it will not absorb the heat transmitted by the magnetron. Non-metallic objects such as glass, plastic can be used as containers for heating your food in microwave ovens because they allow microwaves to pass through and thus cook the food inside these containers. Again, you cannot actually put metals or metallic containers or utensils in a microwave because it will reflect back the heat transmitted by the magnetron. However, not all glass and plastic containers are microwavable. Correct. Microwave-safe containers are specifically designed to resist radiation from the microwaves. Microwaves are also commonly used in satellite communication. Okay, your mobile phones, the one that I had discussed a while ago, and radar used for weather monitoring and navigation in air and sea. Despite these important applications, research findings warn users of microwaves from its harmful effects. Okay. If you are living near the airport, you can actually experience this. No, you are actually exposed to microwaves because their radar is using microwaves in the process, and it is really harmful. Okay. What else? If you're living also near the the transmitting towers. Are you familiar with the transmitting towers? The one used by Globe, Sun, and Smart, and Dito. They have towers, right? It carries the signal, okay, of your phones. It actually hovers the signals. It covers the entire area for the signal. So if you're living near those areas, it is really harmful for you because it emits a larger microwaves. According to research, prolonged exposure to microwaves can cause cataract in eyes. This tells you that avoid putting your face very close to hotter, dry ice, or ice to an operating microwave oven just to check on your food is ready to eat. To eat. Okay. Right. So if you're going to check your food on a microwave, do not put your face near the microwave oven. Okay, because it can actually cause cataract in the process. Another warning brought about by recent research findings is in the use of the mobile phones that can affect some parts of your brain. Okay, you might, okay, take note, you might not aware that it is happening in your brain because you didn't feel anything at all. But it is now happening in your brain if your phone, if you're sleeping with your phone near your head. Okay, remember that when you make phone calls, you're holding a cell phone with a transmitter chip right beside your head, correct? It emits again microwaves that can cause an increase in temperature and when absorbed by your body or brain. Increase in temperature when absorbed by your body or your brain. So these microwaves emitted by your phone will be absorbed by your body and of course your brain because this actually becomes vital for us now as of the moment, especially pandemic situations. We are more exposed to our phones. In fact, when you wake up early in the morning, you usually search for your phone directly, right? You check on your phone. So this becomes vital to us now. But take note, please be reminded that these devices emits radiation, emits microwaves, and can cause harmful effects on your body and your brain. Do you have any questions so far? Any experiences that you have to share?
Yeah.
None, sir.
Okay. If you are young, your brain is still growing, yes. Although the research findings are still inclusive, it is good if we take them seriously. So to prevent this from happening, you should keep your calls short, number one, and do not sleep with your mobile phones beside you or near your head, number two. Again, to prevent this from happening, you should keep your calls short, that's number one, and do not sleep with your mobile phones beside you or near your head, number two. That's the prevention. Remember that prevention is better than cure. Okay? It's better to be prevented. Okay? Than we are now, we are actually experiencing those. Okay. This is actually, you're looking at a microwave. Okay? The transmission and the frequency is in there. So this is usually used by graph with microwave. Okay. How about infrared waves? Okay. Infrared waves have wavelengths between of that microwaves and the visible light in electromagnetic spectrum. By the way, do you have any question with previous discussed topic, the microwave?
None, sir.
Questions with the microwave? All right. Again, infrared waves are wavelength between of that microwaves and the visible light in the electromagnetic spectrum. Most of the thermal radiation emitted by objects near room temperature is an infrared wave. Okay? which are invisible in the naked eye. Special instruments like night vision goggles and infrared cameras allows you to see the infrared waves emitting from warm bodies of humans and animals. Okay, what are the uses? Some of these are used by your CCTV camera. This is the reason why these CCTV cameras can actually have night vision. They can actually see objects because they emit or they are using the infrared waves. Okay, this one is one of the good example. It emits infrared to check on the temperature of each person. Okay, you can actually observe this one in airports and other public areas. You have also your infrared temperature gun. Are you familiar with your thermal gun? Your thermal
The
gun
one
is
they used
also,
in malls, sir.
yes, those thermal guns, okay, uses infrared in the process to check on your temperature. It might not in contact with your skin, but the infrared is in contact with your skin. That's the reason behind. One major source of infrared radiation is the sun. Okay, we are exposed to infrared radiation. More than half of the total energy from the sun reaches Earth in the form of infrared waves. The amount of infrared radiation emitted by any object depends on object's temperature. Okay. Aside from humans and animals, some of objects such as infrared lamps, stoves, flat irons, burning coal, and oven toasters also give off infrared. This is the reason why we can actually feel heat. One good example: if your house has a ceiling which is composed of tin kanang sin in vernacular, it actually if the sun hits if the sun hits your ceiling, okay, it will be absorbed by your ceiling and eventually your ceiling emits infrared. That's why you can actually feel heat inside. And that is the reason behind. Although it is not directly hitting you or directly hitting by the sun, direct sunlight, but you can feel that it is more, it becomes hotter and hotter and hotter because of this infrared radiation or infrared waves. That's the reason behind. Okay. Infrared lamps are also used to keep food hot, relieve sore muscles, and keep chicken and duck eggs warm so they can hatch. Another good example is when you're having your sinugba, okay? You're using a coal in the process, okay? But it is not directly in contact with the coal, correct? But you are using what? The infrared in the process. It is not directly connected, but the heat from the coal cooks your food. Right? Question so far?
None, sir.
They are also used in incubators to keep the premature babies warm for a certain period. Or xenon arc lamp is also a source of infrared radiation and is used in projectors and searchlights, while tungsten filament lamps emits infrared radiation and are used for general lighting and paint drying. One good example again is in the case of the blue babies and in the case of babies that are born with low temperature, hypothermia. Okay. Hypothermic, you say hypothermic, their temperature when they are born is below the normal temperature. Okay, usually it's 20 degrees Celsius above 27 or 30. Okay, that is hypothermia. In that case, we need to expose that particular child in UV rays or this infrared rays, okay, to heat up the body in order for the body to create more heat. Okay. Infrared radiation can cause damage to human body like eyes and skin, but its biological effect depend on the wavelength range between 750 nanometers to 1 nanometer and duration of exposure over a matter of years. Effects are intolerable only if certain doses have been exceeded. Okay. I think we have discussed a lot. Let's continue with the visible light by next meeting because this is quite long and this is one part of the photosynthesis because visible light is being used in the process of photosynthesis. Let's continue by next meeting. Hopefully you learned something out of our simple discussion. Do you have any questions so far?
None.
So far, sir.
All right. Yes, Margie. Yes, Margie. Question? Yes, Margie, yes. For the report sheet. Wait. Let me check first. Still have time. Report sheet for what, Margie? For this module? Last module, Margie? Mm-hmm. Okay, okay. For the ecosystem and biodiversity, you mean, Margie? Did everybody submitted their report sheet?
No, I need it.
Okay. All right. So there you go. Nobody submitted the report sheet. Okay.
I did, sir.
For ecosystem and biodiversity, Q1,
Mm,
module 2, weeks 5 to 8.
7.
Okay, okay. For that, I'll be opening the report sheet for the last time. Okay. Let me check on the settings because Margie is telling me that you cannot actually submit.
Activity 7, right, sir?
Yeah, activity 7. So I will check. I will check. Thank you for the information, Margie. I'll open it today in order for you to do your report sheet. Anyway, I know that you're done with your report sheet. All you have to do is to upload it directly in the LMS, correct? Am I correct?
I uploaded mine already, sir.
Ecosystem and biodiversity. Wait, huh? It is now open. Let me check on the settings. Let me check on the settings first. No online text. Okay, okay. Okay, it's good to go.
Wait, sir, where would you submit it?
In the LMS.
There is no submission box.
In the LMS? You sure?
Yes.
It's
Yes.
in here. Let me share my screen. Diba this is your report sheet? Okay.
Mm,
Review please. This one.
Oh, yes, sir. I submitted already.
You
I
submitted
need
the, oh, let me check on those who submitted. Oh, you submitted without a file.
I
There's
need
no
that.
file.
Really, sir?
Reina also don't have file. Oh, there's no file. It's X. Oh, there's no file there. Wait, let me check on Holly's message.
It's not it.
Yeah, I understand, Holly. Okay, again, grade 10 students. I already opened activity number 7, which is your report sheet. All you have to do is to upload it directly now. It is open until 5 p.m. today. So you have plenty of time, a lot of time, to upload your report sheet in the LMS,
Yes, sir.
right? Please check, everybody, please check your LMS if you can access now activity number 7, which is your report sheet. So this is really important. Is it accessible already? Margie, can you check also, Margie? Is it accessible? How about MD? Is it accessible already, MD? Refresh.
Yes, sir, but I sent the wrong file. Can I do it again?
Yeah, you can. Right. I think that will do for today, class. Thank you for your participation, grade 10. And hopefully you can submit your report sheet because I am in the middle of checking all of those. Okay. Again, failure to submit and failure to do the activity will mean 0. And of course, these will be graded accordingly. All your activities will be graded accordingly. Have a nice day, grade 10. Take care. Bye-bye.
Bye.